minimum and maximum.
This would end up being one of the applications of derivatives.
So are we talking about the minimum and maximum of a derivative, or are we talking about a certain slope? Such as the point at the very least between, like when you have one slope and another slope.
We are simply talking about the minimum and the maximum.
Of the original.
And it will be an application of derivatives.
This looks entertaining.
That is a word.
So I've got 6 different points, A, B, C, D, E, F. And do you see minimum values and maximum values?
Yes. And point A and point F.
Point A and point F. Okay. The minimum that you see, let's see. This minimum value is smaller than that minimum value. Yes. This is also smaller than that value.
Yeah.
Correct. So this simply is the minimum of all minimums. So we can call that the absolute minimum. We'll call it global minimum sometimes.
Why exactly does it change? Sometimes.
It depends on the mood of the mathematician. So that value is going to be the maximum. This value is bigger than that, and that is bigger than that. So whatever maximum that I see here is bigger than all maximums. So that's global or absolute. Maximum. Good. Well, what about the values that are in the middle? There is some sort of a maximum here, a minimum there, maximum there, minimum here. All of those happen on a small interval. For instance, this particular value at B
So this is where we're looking at the other things that we were doing with approximation.
So that is, no, this is different. That is a small interval, and on that small interval, around the value B, that is the maximum that you see. So this maximum is local to that point. So that is what we call a local maximum. Sometimes we also call it the relative maximum. Why relative maximum? This point is maximum relative to every other point in the interval around B. Did you have a question? No. Okay. In a similar manner, do you see another local maximum?
Yeah, that's like D.
D. Using the same logic, do you see minimums? Local minimums?
So the reason why we're talking.
So
How big a concept?
could a function have more than one global maximum? No. Could a function have more than one global minimum?
Yep.
No. Could a function have more than one local maximum?
Oh,
Yeah.
that's
Yes.
local.
Could one have more than one relative minimum?
Yeah.
Yes. Could a function have no maximum at all?
No.
What if it's just
Yes.
yes?
No,
Yes.
Yes, no,
Even if it's a
Why,
small,
yes.
always have a.
Yes.
very good.
Would you just say then the maximum will be 10?
In limited approach to infinity, but there is no absolute maximum. Right, there is a difference between a maximum value and an absolute maximum. You may say the absolute maximum is 100,000, but sure, you could take another x value, get the maximum as 120,000. So your maximum changes anytime you have an asymptote. So that is a case where you don't have an absolute maximum. Let's see, just by looking at it, what kind of function is this?
Exponential.
Exponential. So does it have an absolute minimum?
No.
No, it'll go along the value 0, but it will never cross the axis. In limit, it will become 0. However, if I limit it, say 0 and some number here, 50, hypothetically. This is technically not an exponential because I cut it right in the middle. But regardless, if I said, let's just look between 0 and 50, does it have a minimum? Is it a local minimum or global minimum?
Local.
If I limit to 0 to 50,
It's like local.
it's local or global?
Global.
Global at that point.
Yeah,
That's not the definition, right?
There's definitely.
So
There would be no local maximum.
if I only define from 0 to 50, is that local or global? Global, that's the smallest value of all values. Does it have a maximum? No. But if I restrict it to this point, say 40, does it have a maximum? Yes. Good. So what we have is a line, and I know the y-intercept is negative half. The slope is 3/2. I don't care about how it's sloping, but it ends at 3. So 3 times 3 is 9. 9 minus 1, 8. 8/2, 4. Move that 1. And of course, it keeps on going that way. Does this function have an absolute minimum?
Yes.
Absolute minimum? No, it doesn't. In limit, it goes towards negative infinity. So it doesn't have an absolute minimum. Does it have a local minimum? Or a local maximum?
Yes.
Yes, but where is it at? Can you tell me? So a local minimum, a local maximum, for it to exist, I've got to specify an interval, right? If I pick an interval here, there is going to be a minimum there. Change it here, minimum there. Change the interval, minimum there. So if you want to find a local minimum or a maximum, you need an interval for x. Since I don't have one, there is no local minimum or maximum, but is there an absolute maximum?
Yes.
Where is it at? What is the value? 4.
So we're talking.
Adjust the window. This particular function has an asymptote. Where is that asymptote up? X equals 0. But do I care about that asymptote in this problem? No, because I'm starting at 1. So 1. When you plug in, you get 1. Yes. And it's going to go in that manner. So do we have an absolute maximum? Yes. And the absolute maximum,
The absolute maximum is at 1. Literally both x equals 1 and y equals 1.
does it have an absolute minimum?
No.
No.
Local maximum.
Does it have a local minimum or maximum? It does, but we don't have an interval to specify what that value is. There are infinitely many intervals that I can come up with, so I can't uniquely identify one. Good.
So we would say though that there are no local minimums or maximums because we don't have an interval specified.
Exactly.
Okay.
Just for this.
Okay, so,
What in the hell?
this is a trigonometric function. So what does the graph look like between -π/2 and π/2? Should look like this.
Exactly. And as to how to squirt something, it's back straight.
So, does it have an absolute maximum? Yes. Where is it at?
That's going to be x equals pi/2. If you're asking about the y value, that'd be 1. And
Does it have an absolute minimum?
x equals to -π/2, y equals to -1.
Does it have a local maximum or minimum?
No parameter defined, so no.
No, I've got an interval.
So wouldn't that just be the rule?
You have.
Exactly. Just because I have an interval doesn't mean I have to have a local maximum or minimum. So by interval, I mean, say for example, if I define between π/4 and say π/8, and I asked you, well, what is the local minimum there? You can come up with one. Because on that interval, you have a local minimum or a maximum relative to the global values. See the difference? Yes.
And that would be 0.
That'd be 0.
Yeah, because the endpoints can't be local and the maximum, right? Or-
No, what I'm saying is if I define, for instance, let's even say -π/4, bad drawing, but change it to -π/6 plus π/6, right? And I ask you, well, what is the minimum and maximum on that interval also? Then you would say that's the minimum and that's the maximum. Yes? But relative to those 2 points, these are local ones. Does that make sense? Because these extreme values are defined only for that interval, and relative to the entire domain of the function, these 2 values are local.
So we go.
So I'll let you guys decide the domain on this. What is the domain?
0 to 5.
0 to 5.
Zero, X,
Zero to infinity.
Zero greater than-
0 to infinity, I can include 0 all the way up to infinity.
Which you can.
The
break down.
reason being, I cannot plug in any negative number because I have a square root. Yes, if you graph this. Oh,
You know, I just realized, we haven't really had to deal with imaginary numbers for years.
Don't have to.
So we're just.
don't worry. it'll come.
Pretty, really.
So this is what the curve is going to look like. Does it have an absolute maximum? Yes. Where is that absolute maximum at?
Zero.
And what is the value of that maximum?
One.
Does it have an absolute minimum? Does it have a local minimum or maximum? No, I didn't specify an interval, which would give us a local value. Good, okay.